This is section 8.4, day 1, data variability. Our objective today is to compare data about two populations by using measures of center and measures of variability. Let's start with our vocabulary. A box plot uses 5 points on a number line to summarize a data set, and it shows the middle 50% of the data. So if you look at this picture, you'll see the least value, the lower quartile, which is like lower quarter, the median, which is the middle, the upper quartile, so the upper quarter, and the greatest value. The interquartile range, or shortened to IQR, is the difference between the upper and lower quartiles. So a quartile is like a quarter. Variability tells how much a data set is spread out. We have two measures of variability, IQR and mean absolute deviation. We'll talk about that one tomorrow. So, to create box plots, we have several steps. The following numbers represent distances traveled by customers to get to a restaurant. So, step 1, to create a box plot. There we go. We put the data in order, least to greatest. So we have 1, 2, 2, 3, 3, 4, 4, 6, 7, 8, 10, 11, 14, 15, 20, and 22. Step 2 is find the median, which is the middle. So we cross off one big one, one small one, back and forth until we find the exact middle. 6 is our median. Now we're going to find the median of each half of the data. So the 6 cuts our data right in half. We need to find the median of each of those halves. So I start with this 4 here and the 1 and this 4. And I'm left with a 2 and a 3, so I add those together, divide by 2. The first median, the lower quartile, is 2.5. Do the same thing on the upper side. 22 and 7, 8 and 20, 15 and 10. I've got 11 and 14 left. Add those together, divide by 2. My upper quartile is 12.5. Now, for the rest of our box plot, we'll make a number line. So I've got my number line. My number line needs to at least go from 1 to 22 for this one. So let's call it 0, 5, 10, 15, 20, 25. And if I was not doing this on a computer, I would do every single line as a dot, or as a dash. So the box represents the data between the two medians found in step 3. So that 2.5 to 12.5, there's our box. All right, we mark the median. So our median was 6. So at 6, we make another line. And then we make whiskers that go to the lowest and highest numbers. So our lowest was 1. So there's our whisker. And our highest was 22, which is about here. So there's our box and whisker plot. So you're going to create some box plots for a moment. Now we're going to take a look at this data. A veterinarian collects data about the weights of the dogs she treats. We're going to compare the IQRs of the data sets to draw an inference about the dogs. So we're going to start with our Australian Terriers. I'll call them AT for short. The IQR is the upper median minus the lower one. The upper one is 14 minus the lower is 11. That gives me an IQR of 3. For Boston Terriers, I'll call them BT, our upper quartile is 20, our lower is 17, which gives me an IQR of 3. So what inference can we make? Well, we can say that both types of dogs have weights that vary the same amount. So both types have weights that vary the same amount. So that means that if they tell me that my Australian Terrier is going to weigh 13 pounds, I know that most dogs weigh between 11 and 14, maybe not exactly 13. All right. Look at this one. I want you to compare the medians of the data and use that comparison to draw another inference. All right, for this one, Australian Terriers have a median of 13. Boston Terriers have a median of 19. So one inference we could make is that Boston Terriers usually weigh more than Australian Terriers. Boston Terriers weigh more. And we want to say usually way more than Australian Terriers. You are going to complete the box plot worksheet and then calculate each IQR for that worksheet.